Today's date is the 18th of um, March 2026. I have to put on a board because I've been popping on to. So this is the secret protocol, the drone delivery system for the secret protocol. Without machine learning or training a model, we still have to have this system built in into the firmware because the drone, if it behaves like a drone, if it acts like a drone, it's a drone. And that's what I'm trying to build, the drone framework for the secret protocol. My internet is basically offline, but through my diary. Until I get online, this will be something that the upload so I'll upload this video after. Audacity is coding, no? So without further ado, let's get started. So you have the model I'm using, which is this model here, graph, and you have uh, three-way axis symmetry. One, two, three. This is a triangle, a triangular base pyramid. Let me try and get my calculator. Find it. What's this? Yeah. This is a triangle based pyramid. And the formula is, I choke again, half times half. So this is volume of a triangular base pyramid, which is half times base times height, which is basically this face half of generated others in height. Times an angle times 90 degrees, 90 degrees would be times 5 degrees, or times the slant S, S, which is basically slant the sine times sine S, because we're gonna go up F times sine is slant, sine slant, which means slant, which is basically sine theta. What theta is a slant. Slant, the apex slant, which usually goes up. Cube, cube, cube to the power of 3. Yeah, this does it. Now, the goal is to have this formally introduced via limits. I don't know limits per se, but they deal with gauge systems. But limits to the system is basically when this volume approaches zero, it's not, so yeah, I get it now. Let me do this. So the half of the base times height so will be the formula. So the volume is defined as half of the base times height times the sine of the slant, theta with the slant cube. So you cannot have half of the base times height. And the half will be divided by the base. So the base is the height. If you have the base is let's say 10 meters. The height is 20 meters. Let's say you have the height of the base is 10 meters. The height is 20 meters. Let's say the height is only for the numbers. The height is 8 meters tall. Not sorry, the height is about 8 meters tall. 8 meters. You have the slant of F equal to 47 degrees. You got the sine, cosine to power 3. So this formula will determine the volume to the power 3 of the system here. So we get half 1 divided by 2 times 10, which will give you 5. 5. So you're gonna 5, 10 divided by 2 is 5 times 1. 5 meters squared times the base. Now the base, the height will be 8 times 8. 5 times 8 will give me 5 meters times 8 will give me 40 meters squared times sine. Now the sine is 47 slant, so times cosine times this is sine, this will rise up, and the sine will be what's being calculated times sine slant will be 47, which will give me 29. So the volume is 29.3 meters cubed, because the other dimension is slot, and that's a slot. But but the slant, sure, I just should I add together the slant together? I think I should add the slant together because it's basically less than what we started with. So I made a mistake here somewhere just by looking at the area here. I haven't got anything else to go by. Oh my days, it's so funny. But this is a triangular based pyramid, so it's a 9. Can't be less than what we started with. Can't be. So you're gonna have 29.3 plus sine. This is 14 plus 29 plus 3, which would be plus 8 times 5, which is 40 plus 40. Will give us 69.3 meters cubed. So I will just answer 69.3 centimeters cubed is the volume. So this each region has the volume. Oh wait. No, it's the volume. It's not. So the volume is 29.3 meters cubed in volume. This is volume. That's basically the city side. And that's what I'm saying. But the surface area of the wait, is the surface area of the volume? Never know. I'm just looking at the volume. No, look at the surface area now. That just be triple half the basic height. Yes. So the volume is half the space of height times sine times lot of the system. Which is surface area. It's just the surface area. So the surface area will be squared lots of volume. So I made some mistakes here. I'm very surprised. Let me do it all the time. But I'm proud to not make to not be not this one mistakes instead of being wrong. So we're gonna have this length be 29.3 meters squared for each surface. So the total will be 29 times 3.3 times 11 will be 29.3 times 3, which will be 87.9 meters squared for all the three faces. 1, 2, 3. 1, 2, 3. Oh, there are four faces. 3, 4. There are four faces because there's one on the back. So you've got four faces in net. Based on net geometry, so there's four faces. So it will be 29.3 times 4. And that will be 1172 meters squared. These are faces. These are faces. These are net faces. So you get the front face, the back face, the two side faces, the front face, the back face, the bottom face, and the bottom left, right, and top face. Bottom left, right, bottom left, right. No, bottom one. We'll try to draw it again. Um, 1, 2, 3. Excuse me. 1, 1, 2, 3. So this is, yeah, we've got three faces here. For triangle with no four faces, so basically 89, you got to think 29.3 times 3, which is 87.9 centimeters of square in the face of 87.9 centimeters of the face is square, a meter squared in face. So basically, what I do here, I'm trying to determine how this three-axis reflecting sigma will work. Because it's gonna move around based on the image time. And this is basically the kind of system in place of the drone. Gonna be a front, a left control, a line control, and four faces. 4, 1, 2. Let me think this was I don't know. One, 2, 3, 4. 1, 2, 3. 4. So 1, 2, 1, 2, 3, 4. There are four faces in total. No, it's 3 faces. 1, 3. is I don't know, I'm making a mistake in my own math. You can't see the back. So if I have the net will be this one, because this is fold up. This one, this one, fold up. So basically there's a four. Yeah, this is net to the key. So they're gonna have this is basically the net. And the net of the trapezoid has four sides, four faces, and not three, which basically means 29.3 times 4. 29.3 plus 4 should be 11 point, or 117. 1 times 4 should be 117.2 meters cubed, meters squared of total volume from 29.3, which was the sine of 47 degrees. You see an obtuse angle. No, it was a cube. So everything has 47 degree angles plus sine, and the index at the apex cell. The apex would be top here. So basically left, right, middle, and bottom, base. And this is brilliant. So the actual symmetry of this shape is literally where it's reflecting off. So you get a asymmetric symmetric model because this doesn't have a symmetric axis. So this has one axis symmetry, one axis symmetry, only one axis symmetry, and everything. The shape is symmetric. So this is shape reflects, which is says that it's asymmetric model on the face, which we don't try to define for some. So the next step is to introduce what this. So you have the drone moving up and down, and this symmetry is the drone watching its own path. So the drone can watch left, itself, middle, right, and the base on the bottom. These are four cameras and produce points based on the auxiliary vector where it is. So mathematically, this will be defined as a surface vector, produce points of a surface using the Manhattan distance, no, Hamming code. Hamming distance, Manhattan distance, which means. So you're gonna have the volume of whatever the common principal point is. So next question. Let me try and do this properly. How many before? Is there anything to define which domain? No. No. Let me move to the next thing. So you get 29.3 times 4. I don't know. You want this one here. Draw it again. Vote. So you're gonna have 9.3 times 4. So you try 2.3, 9.3 times 4. Write it and frame it and sign it. Write it, frame it, sign it. So you have a reflective room, asymmetric, symmetric construct, which is basically the surface that you can build on top of it, but within the surface net of the geometry space, they're going to integrate over using surface integration, which I do not do. Funny enough. So you're going to have a computer that is free now, you're going to use it. So you're going to have the surface Of 12. Yeah. What's next? My clock is done. My first clock is done. So imagine you have nets, and the nets resemble something like control switches. So you're gonna have four nets in this model, or four nets that have some kind of force on it, operating on it. Uh, in a pivot system, in the return system, you have to return via a curvature of the space time. So you're gonna have four faces. So you're gonna have answer fly. The base. Um, Times the height. Times the left. Times the right. And this was referring to usually what is known as gold. This is net of a pyramid. And the volume is the line is you're gonna have half the space has basically 10 meters. The base is 10 meters. Half of it is 10 meters and a half will be 5 meters. 5 meters. The height is 8 meters. The acute angle theta is 47 meters, 47 degrees, which is basically sine 47. So again, half times the base times height times theta times sine theta, which is the surface of the surface area of a volume, the surface S equals half times base times height times sine theta. And theta represents 10th times a half. Okay, or 10 divided by 2. 10 divided by 2. 10 divided by 2 is 50. 50 times 8 is 14. 14. 40 times sine 47 will be 29.3. 29.3. meters meters squared of surface area times 4 times 4 will be 1029 meters squared times 4 is 1170 meters squared. And so basically the left side of the system, the right side of the system, the based on asymmetric symmetry mapping. Basically, you're gonna have a line of symmetry in the center, a line of symmetry in the center, a line of symmetry in the center of the net, a line of asymmetry in the center of. Oh, you have 4 lines of asymmetry here. So it's not. You have 4 lines of asymmetry. Yeah. So basically, yeah. So you're gonna have 4 lines, 4 disjoint lines. So it's going to change. So when you check again.
So it's not going anywhere. It's we've got first. He's only going to work with me anyway, so it doesn't matter. We ain't getting to know what else because he knows how the sisters and needles. I know the staff. I've known him since I was 16 years old. Yeah. It's not like we're all passing. At the end of the day, you stand at the hospital, you go an hour and a half there, an hour and a half back.
Yeah, so you're gonna have a system there. So you're gonna have 4 lines of symmetry.
Do you know what I mean? So you know what, I think you just the same. You got to stop that.
So you're gonna have 3 lines of symmetry.
We just don't get away from him if we do that.
You're gonna have 4 lines. 1, 2.
I need to clean my clothes.
No. You're gonna have 4 or 3 lines of symmetry. And it's asymmetric studies. So you get symmetric, asymmetric, symmetric, asymmetric. Anyway, this one's saying, so I've got here now. My work. But I'm trying to model this properly. So basically what this represents. So I'm just showing you that I calculate the volume, but I'm trying to increase the volume. So surface area can be integrated over based on the field of view. So this left represents the field of view, this right represents the field of view, this base was a field of view, bottom and field of view. So the field of view very applies. But the field of view is basically the field of view which is done to calculate. So these are all fields of view. And you're gonna have them follow the standard springs. Just follow the standard 1 minus t times c times t times p, which is basically 1 minus c t times c, which is basically the breaking point of the system. Which is which I will two points. Closing the curve, this is basically as the system moves away from the field of view, you can always look at some other sign, control, so you can get to the destination. But I've discovered that magnets are literally eyes can act the eyes. If you have an artifact, you compare a runtime, a compile time, the code executes at runtime, but it can keep going, the code can keep executing as long as it is in the 3D space. So this rule can keep going, it's magnetic, it really knows the runtime procedure to follow. And it's just like a blind, it was not an ES system, it's just like you put a drift thing. So, that's what I'm saying. So this left, right field of view, field one, view of Johnson, the eyes of drum and is of drum, and they're just the eyes of drum. So you get a field view of 316. So if you put it to a ratio of 2 pi, you have a period 2 pi, which is literally 1 period of a minute. You're gonna get pi, half pi, pi quarter. So you're gonna get pi divided by 4, a quarter of pi. So basically 3 pi, you're gonna get pi is 1 period, pi is half a period. So half a period is just pi. You're gonna get pi divided by 2, pi divided by 4. So you're gonna get So um so periodically for visual spin. So the more it's or the more you say, the more you know about the system. But this is a field of view. So the left field of view, the right field of view are literally the area of the still, usually of your distance of drift. So answer the ball is properly. Mhm. Okay, I think that's what your video. My phone's gonna die now. I can't continue this video.